Welcome to the another video of the basic electrical engineering. Here we are trying to represent the power in phasor form. Just from the previous exercise, we know that if V is angle 0 and IL is I angle minus phi, we can write in the equation form also V is equal to Vm sin omega t, IL is equal to Im sin omega t minus phi, and we can get the equation of the power. What does it mean is that if the voltage is taken as a reference and the current is lagging by an angle of phi, minus of phi here, V, and this is I angle of minus of phi, like this. So that is a representation and we get the power here. So we had to find the phasor form of the power here. So now we have got let's try to make a generalize of it. Let us say this is the x-axis and you have got a y-axis, and let us have a general notation of here of V. So V is of angle positive phi alpha angle is there. So let us change this color and draw the value of V. So V is made with an angle of alpha and I is made with an angle of beta, where let us say beta is greater than alpha, or let us say, okay, let us draw in such a way that the current seems to be lagging. So let us say alpha is greater than beta. So if the voltage is over here and if this is a V angle alpha, this is alpha degree, and the current is also there, and which is of angle beta, this is a beta value. You have got alpha value and beta value, and this angle between them is obviously the alpha minus beta is the angle between V and I. So we try to make a general form of it and try to get what will be the power equation if you have this is the voltage and current. So we try to get an equation of the power taking the term with V angle alpha and I angle beta. So just to take this equation and solving, we get a 2 sine omega t plus alpha sine omega t plus beta, taking this value, and when we find of cos of solving this, cos of A minus B is alpha minus beta minus of cos A plus B, cos of 2 omega t plus alpha plus beta, and we split out, and this term we try to write in terms of alpha minus beta so that we can have a same pattern of the previous equation. This is a pattern when we have taken just V and I angle minus of phi, we get this pattern, one active term with 1 minus cos 2 omega t, one reactive term with sin 2 omega t with a minus in between. So here also we get a term with alpha minus beta, and this thing is being split out into cos A minus B, cos A cos B plus sin A sin B, and after splitting this out, what we get is here if we get a total term, this is active term, minus 1 minus cos of 2 omega t plus 2 alpha minus of Vi sin alpha minus beta sin of 2 omega t plus 2 alpha. Again we get a value of, let us say alpha is equal to 0 and beta is minus phi, alpha minus beta will be phi, and we got the same expression as this one. So this is a valid expression if you have any general angle as alpha and beta. So in this phasor diagram, so earlier from the equation, the active term that we have got and the reactive term we have got, let us write. So active term we have got is Vi cos of alpha minus beta, and the reactive term that we have obtained is Vi sin of alpha minus beta. So when we want to have a phasor multiplication to get the value of the power, so the power equation, power will be, obviously the power is given as Vi, but here we will introduce a new term that we will have a phasor multiplication, but we will not write Vi, rather we have to say Vi star. The star is a complex conjugate of I. Suppose I is equals to, suppose a vector is there, let us say R is equal to A plus JB. When I say R dash, it is A minus JB. That's the only difference. So there is a two term is introduced, V and I star, that is a formula of the power. So it must validate in this term. So how we can write? We can write power is equal to V angle alpha multiply with I angle beta, and the star is there, so because of the star, this instead of beta it will be minus of beta. So now we have V, this term is split as V cos, we can make a cos of alpha plus J sine of alpha. So similarly here for I, we will write I cos of beta plus, sorry, the minus is there, so it will minus J sine of beta. So this is the what expression we get. So we can write here power is equal to, so let us take Vi out. Here we have cos and cos beta, so cos alpha, cos of beta, and J term is sine alpha, sine beta, so J square, so J square and negative is add up, sine alpha, sine of beta. Again we have got a J term, so let us say J Vi, Vi taken out, and here the J term is sine alpha cos of beta, so minus term is there, so minus sine beta cos of alpha. So this gives me the expression like Vi, this term is nothing but cos of alpha minus beta, and plus JVI sine of alpha here minus beta again, this term. So from this expression of P, we are now we verify that yes, this expression of power what we get is the same expression what we get here, this for active and reactive power. So for that reason we can say that to get a value of the active and reactive power in this format, we have to write P is equal to Vi star. So we can have that notation Vi star. Also from here we can have a reflection of like this is the Vi sine alpha, V sine alpha, and this is I sine of beta. This one is V cos of alpha, and this one is V cos of beta, and we can do this multiplication. Otherwise see this values is alpha and this values is beta, and this one is alpha minus beta. So we validate that this is the expression of the power from, because it matches whatever the value we are getting, it matches with the active and reactive power. So now the value of P active and P reactive is like this cos term and sine term. So if we do a square term of it, P active square, so you'll get Vi whole, the whole term is getting square up, cos square alpha minus beta, and here if I do V reactive square, this is nothing but Vi whole term is getting square sine square alpha minus beta. So if I take addition of these two, like P active square plus P reactive square, if I do, I will get the term like Vi square. So I can say the total power is P is square. So from this we have a term like what is P, total P. This P is called the apparent power, is the total power what we have. So to represent in the phasor form, if I represent the total power in this, so let us say this angle here is the angle is there, and this angle is alpha minus beta. This is the angle, and it has got a cos component, it has got a sine component, and let us say this is Vi, this line is Vi, so it has got a Vi cos component of it, and it has got a Vi sine component. So here we have a Vi is a like apparent power as a total power that is being let us say the load is there, right? So you have got a resistor and inductor in the load, or you can have we have seen that a resistor and a capacitor in the load. So if the total power that is consumed is here, we say, okay, total power which is being at any instant of time is coming, total power is the S, and that S is called VI. Out of the S, the power which is getting consumed or absorbed, that power is the active power. This is the power which is converted into heat, which is converted into light, or which is converted into work some done. So that is a power power which is used as a heat, light and work done. Heat, light and work done, this will be coming under the active power. And the power which is there to maintain the oscillations between that R and L, or between the L, there is because L will be active only if it is a AC current. So it needs power to maintain some energy, and that energy is being received, and once in a one cycle 2 times the energy is received and 2 times the energy is fed back. So it is like energy is received and taken back, so that energy is maintained through the reactive power. So this is just like one type of energy is maintained in the inductive circuit. So when there is an inductor or there is a capacitor, this energy is taken in and out twice in one cycle. In that way, there is a term like alpha minus beta is the angle between them. So you can consider this for the lagging, also for the leading. Only difference when it is a lag, the voltage is V and the current is with the angle minus phi. So when it is leading, the current is leading by an angle of phi. So you have got the components right now with you. Is that now you understand what is active and reactive? So here, once you have the current here, so the current has got 2 components. One is that let us draw it clearly. So that V and I with the I cos phi, which is the component along with V, and I sin phi, which is a component quadrature to V. So we can get a multiplication of these 2 terms, which is V I cos of phi. We can take this term to the upper one. We can rotate it by an angle of 90 degree. So when we rotate this term with an angle 90 degrees, so it is obviously multiplied with J. So J I sin phi with V multiplication. So here we get a term, 2 terms. One is V I cos phi, one is V J I cos phi. So this term is nothing but V I cos of phi is P active. So another term which is that after rotating this I sin phi by angle of 90 degree in the anti-clockwise, that is why we multiply J to it. This is J V I sin phi. It is the quadrature component. So reactive part, reactive. So we can write also that P active plus J P reactive is equal to total power P. So that statement is also correct. Here P reactive, we can say J into P reactive, because P reactive is a component of VI sin phi, which is multiplied with J. So this is the expression of the power in the phasor form. Also we have a power in the waveform equation that we have seen, and from the waveform equation we have related the power in the previous video also, and we have detailed explanation. We have explained nicely that how the power will be shown, if the active power, and how the reactive power is being shown here. Also you can have an instantaneous power out of it. So that is because you can take, let us say, with an angle of phi, and you can have a instantaneous power with V and I. So there is the instantaneous power at any moment will be like sum of the power which is there in the active, because it is like plus sign with the total instantaneous power PRL. So at any moment of time, if you have addition of instantaneous power, so it is like addition of active power and reactive power. So at this particular moment, you have a 90 degree, you have got the active power is this high value, and this reactive power is here 0 at this particular time. So you can put here omega t and you can get this is Vi cos of phi. So in this way you can have the addition and subtraction, you can addition of the apparent power and the active power, and you can get what is the total reactive power and the active power, and you can get what is the total apparent power. So apparent power is the sum of both active and reactive. In that way you can calculate. And however, if you have the RMS value of the active power and the RMS value of the reactive power, then you have to do for the total sum and evaluate what is the total power and take the Phasor addition on the A plus JB term, and then you have to calculate what is the total power out of it. So finally what we conclude is that we have got the active term here and we have got a reactive term which represents the energy maintained in the device or circuit. Active, which is the work that is being done, and the total power is the square root of A square plus B square. In that way, and the total power is the apparent power. Apparent power is total power is required from the supply end. Even though the apparent power is taken and given back, but some power is required to maintain it. That is why the total power is Vi. That is, and more the value of the, you can see from the phasor diagram here, larger the value of the phi, so the active component get reduced and the reactive component is increased and work done. So if we have suppose you have the current which is of not lagging so much and less value, so you can find if an inductor is of lesser value, so the active part, for this much active part you need this much of current. Like this is suppose I1 and this is I2. Suppose you have an active fixed part is there, and from the low supply you need I2 current only. But if the inductance is more in the circuit, from the supply you need I1 value of the current. So larger the value of inductance, so you need more amount of current from the supply, and this current which is taken from the supply will be affecting the transmission line, because in the transmission line the current is coming through the transmission line, but in your meter you are showing only the Vi cos of phi. So it will affect, higher the value of the inductance, it will affect the supply system and it will draw more amount of current for the same work to be done. So more detail can be discussed in the higher semesters. So till now you will be now very clear about what are the difference between this apparent power, active power and reactive power. Thank you very much. In the next videos we'll be having the another circuit with the RLC and see that what is the resonance frequency.